Yesterday we have seen about the Williamson synthesis, my dear students. We have seen in the Williamson synthesis that mixed and symmetrical ethers can be prepared by Williamson synthesis. So you can see here that if we take the alkyl halide, this alkyl halide should be primary and this can be secondary, tertiary, or it can be primary, whatever you wish. But this alkyl halide should be taken primary. So if we take the alkyl halide primary, then in this manner we get the product. So you can easily understand here that, see, if your sodium alkoxide, if your sodium alkoxide is primary, your sodium alkoxide is tertiary, then it reacts with the primary alkyl halide and give us the mixed ether. So this is how, my dear students, we understand. But if we take the alkyl halide tertiary, then there will be competition between the elimination and substitution, and we get the eliminated product, which is an alkene. The same we have understood with the examples also. Then we have studied about the alkyl aryl ethers. So if you have any alkyl aryl ethers, or we have studied about the preparation of the ethers from the phenol. So if you have phenol, you allow it to react with the sodium hydroxide. So you get sodium phenoxide. And this sodium phenoxide, when it reacts with the alkyl halide, which is primary, it gives, or which is primary, secondary, or tertiary, it gives us the ether. But generally, for the Williamson synthesis, the alkyl halide is taken primary. The following is not an appropriate reaction. You can see we have seen one reaction which was not appropriate. The reaction was not appropriate because in the reaction, the sodium alkoxide taken was primary, but the alkyl halide was taken tertiary. So if the reaction takes place, we will get alkene as a product, and this alkene will be obtained as a product. But if we want to get the same product, we shall have to take the sodium tertiary butoxide and chloroethane, so that we can get the butyl ethyl ether, as it was shown here. It's a tertiary butyl ethyl ether that we get, my dear students. Now, my dear students, we want to study, or we have even studied about the, I don't know why the pages are being, they jump away. So I'm just trying to go to the next page. You can see that we have studied about the physical properties, and we have observed that the boiling point order for hydrocarbon, ether, and alcohol, we can easily understand that alcohol have the highest boiling point, then ether, and then hydrocarbon. But when it comes to the solubility, my dear students, ether can even make the hydrogen bonding with water, and that is why ethers are quite soluble as compared to the hydrocarbons, and they are miscible in a comparative amount with the alcohol. So as alcohols are miscible with the water, ethers are also miscible with the water, and their solubility is comparable with the solubility of alcohols. Then, my dear students,
खिलाओ में भूख लगी हूँ बड़ा है
the cleavage. So, my dear students, when it comes to the cleavage, we generally we can see that the cleavage, whenever takes place when the ether reacts with the hydrogen halide. So if the symmetrical ether is there, then the symmetrical ether will give us the two same alkyl halide. But if the ether is not symmetrical, we will study, or we will study it today. But we have even see that if we have the aryl ether, then aryl ether will definitely give one of the product as a phenol. This is what it is for sure, that you can see here. This is what it is because this bond is very stable, and that is why the bond between oxygen and phenyl ring does not get broken easily, and we can get phenol or derivated phenol as one of the product. Then, my dear students, we have started studying the mechanism for the reaction between the symmetric or unsymmetric ethers and alkyl halides. We have seen that the reaction takes place into the three steps. This is the general reaction. So you can see that the more negative part, that is iodine, get bonded to the uh, part of ether or alkyl group which is least substituted, whereas the more substituted alkyl group gives us the alcohol. Let us understand this mechanism in detail step by step. In this mechanism, in the first step, there is an attack of the electron present into the ether on oxygen, on the hydrogen present into the hydrogen halide, so that we can get the protonated ether, or we can get the carbonium or oxonium ion. These oxonium ion, my dear students, now iodine minus, I minus attacks into the second step. This I minus always attacks on the oxonium ion, always attacks to the part of the oxonium ion which on the carbon which is least substituted. So iodine always attack on the least substituted carbon, or you can say the small ring, small chain. So iodine always attack on the small chain, and that is how we get an intermediate. And then finally we get the iodine bonded to the small chain, whereas the alcohol that is obtained in the with the bigger chain, or the alcohol is obtained with the long chain of carbon. Now, my dear students, this alcohol in the third step, again it is attacked by the hydrogen iodide, and then we get again the protonated alcohol or oxonium ion. Iodine again attack the alkyl group, and thus again the another alkyl halide, and water is produced. So this is how, my dear students, we understand the mechanism for this reaction. Now, this was the first example of the bond cleavage uh, into the CO bond. Now we want to study the another example. You can see here, my dear students, that this ether has got two alkyl group. This is what it is having, two carbons. This is what it is having, one, two, three, four, five carbons. So this is more substituted, this is less substituted. It reacts with Hi. We know that iodine attacks on the less substituted carbon, and that is why we get ethyl iodide, whereas we get 2-methyl butanol as a product. So, or you can even say, so this is how, my dear students, when this is the example that explain us how the hydrogen iodide reacts with the ethers. Now we'll look into the third example. Here we have, this is the tertiary group, and this is the primary group, this is the least substituted group. So we can easily understand that the iodine will attack the least number of carbon part, and the iodine should attack the least number of carbon part, but instead of that, the iodine does not attack the least number of carbon part, but iodine attacks the carbon present over here, that is the tertiary group. So we get the tertiary alkyl iodide, and we get alcohol. Now why this happens? What is the reason that this example 3 takes place and we get, so this is again a particular situation. If there is a tertiary alkyl group present into ether, then iodine will be bonded to the tertiary group. When tertiary alkyl group present in the ether, halide formed is tertiary halide. Why it happens? Let us understand it with the help of the mechanism. So if we have tertiary alkyl ether, the oxygen present on the the electron present on the oxygen of ether attacks hydrogen, and we get the oxonium ion or protonated ether and iodine. Now in the second step, you can see that this oxonium ion in a slow process make stable carbocation, tertiary carbocation. So the bond between the carbon and oxygen is broken, and that is why we get CS3OH or methanol. Now this carbocation in the third step, it reacts with the iodide ion and we get the tertiary iodide as a product. So please remember, my dear students, that if in ether primary and secondary group are present, the iodine is going to bonded with the least substituted group. But if in ether there is tertiary alkyl group present, then iodine is going to combine with the tertiary alkyl group. The same we can see here in this example, that this group is again a tertiary group. So this is the tertiary carbon, which is going to give us the iodide, whereas this long chain of carbon will give us the alcohol. Please remember that between the reaction of ether and hydrogen iodide, if the alkyl group present in the ether is tertiary group, then in the reaction with hydrogen iodide, tertiary group will give you uh, al, uh, alkyl iodide, and the other group will give you the alcohol. So this is how we can understand, my dear students. Now, my dear students, we are going to study about the electrophilic substitution of alkyl and aryl ether. Please try to understand this point given, electrophilic substitution of the alkyl and aryl ethers. So you can see here that the alkoxy group OR is orthopara directing in nature, and it activates the aromatic ring towards the electrophilic substitution reaction. Now, the reason that why the alkoxy group is orthopara directing, you can see that this is ortho position, this is para position, this is again the ortho position. And electrophile is E plus. So E plus can easily attack on the carbon where you get the negative charges, and the negative charges are formed on the either second position. You can see here the negative charge on second carbon. On the fourth position, you can see the negative charge on fourth carbon. On the sixth position, you can see the negative charge on sixth carbon. That is your, both these are the ortho position, and this is the para position. That is why this this alkoxy or alkoxy group, OR group, is orthopara directing in nature, and in the various reaction, you will see that our anisole, or you can see that methoxybenzene or anisole will give us the product which are the orthopara directing. So let us first study about the few reactions given by them. Let us have a look to the different reaction given by anisole. You can see first the reaction which is known as the halogenation. So let us first understand about the halogenation. Anisole, when it reacts in the Br, bromine, which is dissolved into the ethanoic acid, it gives us the para-bromoanisole and ortho-bromoanisole. This para-bromoanisole is also known as the 4-bromoanisole. Ortho-bromoanisole is also known as the 2-bromoanisole. We know that in ortho position there will be steric hindrance, and due to the steric hindrance, ortho product is less, which is the minor product, but para product is major product. this is the halogenation of anisole. Now, my dear students, we are going to study about the nitration of anisole. So you can see here, we have the nitration of the anisole. The nitration of anisole is done in the presence of the sulfuric acid and HNO3. Due to nitration, my dear students, we get orthonitroanisole and para-nitroanisole. Orthonitroanisole can also be known as the 2-nitroanisole. Para-nitroanisole can also be called 4-nitroanisole. And this is how the nitration takes place. Remember, my dear students, that ortho product is minor, whereas para product is major due to the steric hindrance. Now, my dear students, we will study the another reactions of the anisols. First, my dear students, we are going to study about the Fiedel-Crafts alkylation, and then we will study about the Fiedel-Crafts acylation. You can see here the Fiedel-Crafts alkylation of the anisole. To add the alkyl group like methyl group or ethyl group, instead of CH3Cl, if we take C2H5Cl, then there will be ethyl group bonded to the benzene ring. So we take CH3Cl and anhydrous AlCl3. Due to this, the Fiedel-Crafts alkylation takes place and we get 2-methyl-toluene or 4-methyl-toluene. We can even call them as ortho-methoxy-toluene. 2-methoxy-toluene and 4-methoxy-toluene, we can also call them ortho-methoxy-toluene. Ortho-methoxy-toluene. Or para-methoxy-toluene. You can easily understand due to steric hindrance, the ortho-methoxy-toluene is minor, whereas the para-methoxy-toluene is going to be the major product in this case. Now, my dear students, we are going to study about the Fiedel-Crafts acylation. CH3CO group is known as the acyl group. So you can see here the Fiedel-Crafts acylation reaction. You can see that anisole, when it reacts with the CH3COCl, it can also be allowed to react with acetic anhydride. So we can use here acetic anhydride even, CH3CO twice into O. And this way, this acyl group, CH3CO group, is bonded to the benzene ring. So we can have, this is what it is known as the acetophenone. On benzene, if we have COCH3 group, it is known as the acetophenone, and that is why the two different products that we get are known as the 2-methoxyacetophenone and 4-methoxyacetophenone. You can easily understand that such a big group, when they are near, there will be steric hindrance, and that is why this product is minor. But when they are available on the para position, steric hindrance is minimal or is decreased, and that is why we can say that 4-methoxyacetophenone will be the major product. This is how, my dear students, we can understand about the various reactions that anisole gives. All these reactions, nitration, halogenation, Fiedel-Crafts alkylation and Fiedel-Crafts acylation, are known as the electrophilic substitution reaction. So I hope, my dear students, you have understood it well. If you could not understand it, you can ask me your doubts, or we can move to the next part. Do you have any doubt, my dear students? बच्चों
No,
क्या
sir.
आप कुछ पूछना चाह रहे हैं? Okay, then let's move and solve few of the in-text questions from the textbook. Let us pay attention to this. Let us study the various in-text questions that we need to study. First, we'll go with the in-text question 11.10. Write the reaction of Williamson synthesis of 2-ethoxy-3-methylpentane starting from ethanol and 3-methoxypentane. So we want to get a particular product using the given reactants. Now we have 3-methylpentane 2-ol, which we will allow it to react with the sodium so that we can get the sodium alkoxide of that particular alcohol. Ethanol is allowed to react with the HBr so that we get bromoethane. Now the primary alkyl halide preferably reacts with the secondary alkyl halide, secondary alkoxide to give us the desired product. Remember that here the idea that the bromine means we will have to take bromoethane. We cannot take the sodium ethoxide because the alkyl halide that we use for this reaction should be primary because the another alkyl group is secondary. So please remember this, that in such kind of reaction we prefer the alkyl halide being primary. Now the next question. Which of the following is an appropriate set of reactants for the preparation of 1-methoxy 4-nitrobenzene? You know 1-methoxy 4-nitrobenzene is your this compound which is 1-methoxy 4-nitrobenzene. Now which one will give us the exact product? That is what we want to know. Here we have CH3ONA, here we have CH3Br. Now which one will give us the exact product? That is what we want to know. We have just seen that alkyl halide should be primary. So here the alkyl halide is primary, and as the alkyl halide is primary, this is what it is going to be very useful or the correct set. So set 2 is an appropriate set of reactant for the preparation of 1-methoxy 4-nitrobenzene because phenols are converted to ethers by Williamson synthesis in which phenol is used as a phenoxide moiety, and set 2 has phenoxide moiety, my dear students. You can see here that whenever we want to prepare the aryl ether, we need to have the phenoxide moiety. And set 2 has the phenoxide moiety, and that is why set 1 does not have. You can see that here set 1 has a not phenoxide moiety as well as, but here we have the phenoxide moiety. We even have the benefit of the primary alkyl halide. Please remember this sentence that when we want to prepare the aryl halide, we need phenoxide moiety as one of the reaction during the Williamson synthesis. Now, my dear students, we have the next question. Let us look at the next question. Predict the product of the following reactions. So we need to predict the product for these reactions. You can see CH3, CH2, CH2O, CH3 and HBr. Now you are well aware that the negative part will attack on the CH3 part because both are primary alkyl group, and we will get CH3Br and CH3CH2OH. Same way, my dear students, please remember that during the reaction with HI, phenol and oxygen bond is very strong and that cannot be easily broken. So phenol and oxygen bond will not be broken, and we will get phenol or derivative of phenol as one of the product, and that is why C2H5, this H goes with the oxygen and C2H5 combined with the Br, and we get C2H5Br and phenol as the product. Same way, my dear students, we are going to do the nitration here. So we have ethoxybenzene. This ethoxybenzene, they are orthopara directing, and due to nitration, we get orthonitroethoxybenzene, or you can say that one 1-ethoxy 4-nitrobenzene and 2-ethoxy or 1-ethoxy 2-nitrobenzene. This is how we get the major and minor product. The ortho product will be minor and para product would be major. Now you can see here that this carbon is bonded with 3 other carbon. That means it is the tertiary group which is present into the ether. When there is tertiary group present into the ether, this carbon combine with the iodine and this hydrogen combine with the oxygen. So you will get ethanol as one of the product and tertiary alkyl halide as the product here, even my dear students. Then we'll study the next question. Write the adverse effect of drinking ethanol. So what happens if we drink ethanol? Ingestion of ethanol acts on the central nervous system in moderate amount. If you take the ethanol in the moderate amount, it affects the judgment and lowers the inhibition. Higher concentration, if you take, my dear students, that higher concentration can cause nausea, it can cause the loss of the consciousness. Even if you take the higher concentration, then it causes the interference with the spontaneous respiration and it can be fatal. That means it can cause the death. So once again, my dear students, if we take consume it into the smaller amount, it affects the central nervous system. In moderate amounts, we loses the judgment and we cannot do a proper inhibition. We cannot walk properly, we cannot think properly, and at higher concentration, it causes nausea, loss of consciousness, and it may even interfere our spontaneous respiration and can cause death. Next question, my dear students, write the uses of the diethyl ether. So here, my dear students, we are going to study the various uses of the diethyl ether. Diethyl ether has been used widely as an inhalation anesthetic. So it was used, please remember. But due to its slow effect, the effect of diethyl ether is slow and unpleasant recovery. When a person becomes conscious, it feels unpleasant if diethyl ether is used as an anesthetic, and that is why it has been replaced by the various anesthetics or various other anesthetics. So this is how, my dear students, we can easily understand that diethyl ether has got the utility as an anesthetics. But due to some reason, what are the reason? Unpleasant recovery and slow effect. Nowadays, it is not much used as an anesthetic. Now we have the next question. Give structures of the product you would expect when each of the following reacts with. So butanol, my dear students, your butanol CH3, CH2, CH, your butanol, my dear students, when reacts with HCl and ZnCl2. Your butanol is primary alcohol and ZnCl2 oblique HCl is ZnCl2 oblique HCl is known as Lucas reagent. So as it is the Lucas reagent does not give any product with the primary alcohol. So we can write no product. But with hydrogen bromide, it will give the bromoalkane. So as it is butanol, it will give us the bromobutane. And with SOCl2, which is a very good chlorinating agent, it will give us the chlorobutane. So this is how, my dear students, we understand the various products in this particular case. Now we have the another compound given to us, which is 2-methyl butane 2-ol. So you have 2-methyl butane 2-ol. You can see the structure. So the oxygen bonded to the carbon is bonded with 1, 2 and 3 other carbon. So it is tertiary alcohol. And tertiary alcohol with the with the ZnCl2 and HCl, which is the Lucas reagent. give immediate turbidity. So it will give us the immediate turbidity by producing the 2-chloro-2-methyl butane. So this is how, same way when HBr reacts with it, it gives us 2-bromo-2-methyl butane, and with SOCl2 it gives us 2-chloro-2-methyl butane. So this is how, my dear students, we get to know the various products that we may get from these various reactants. Now, my dear students, here I would like to ask you, if you have any doubt, you can ask me. बच्चों, अगर आपको कुछ समझ में नहीं आया है तो आप लोग मुझसे पूछ सकते हैं, और अगर आज की जो डिस्कशन है उसमें सब समझ में आ गया है तो लेट अस stop the class and you can move for the next class. Dear students, if you do not understand anything, you can ask me, or if you have understood everything, you can move to the next class. Dear students, you can leave this meeting and go for the next class. बच्चों, अगर कुछ समझ में नहीं आ रहा है तो पूछ लीजिए, या अगली मीटिंग के लिए जाइए. आज यहाँ पे क्लास को खत्म करते हैं. एटलीस्ट बताते जाइए कि सब समझ में आया कि नहीं.
Yes, sir.
ग्रेट. आप लोग जाइए. चिराग कलमी, यू आर नॉट सिटिंग ऑन द क्लास.